All right, guys, so we started chapter, okay. So we're continuing on with chapter 5.1 today. Yesterday we talked about naming triangles based off their sides and angles. Because if a triangle has three congruent sides, then it's equilateral. If it has three congruent angles, then it's equiangular. And really those two will go together. If a triangle is equilateral, it's going to be equiangular. If a triangle is equiangular, then it will be equilateral. Now we'll get into more detail later on in this chapter of why those two stick together and will always stick together. And then we talked about having a triangle that is scalene, it has no congruent sides, or isosceles, where it only has two congruent sides. Then we also had triangles that are acute, right, or obtuse. They're acute if all three angles are less than 90 degrees. It's right if it has exactly one right angle, or it is obtuse if it has one angle that is obtuse. And then pretty much that's all we covered yesterday, because we went through naming triangles and then we named them by actually using the distance formula to find the lengths of the sides and using our properties of perpendicular lines to determine if a triangle was a right triangle or not. Now what we're starting off today is when the sides of a polygon are extended, other angles are formed. The original angles are the interior angles. The lines that's formed with the interior angles are extended to be the exterior. So the main exterior angles that we look at are going to be the ones that make a straight line with the interior angle. We can pick how we want to set that up, but really the interior and the exterior angle will make a straight line. Well, and I will say this again because I feel like I've said it before, a lot of the times when they name mathematical things, it's really exactly 100% what it is. They don't come up with something creative with it. Because interior angles, well, interior is inside. Well, where are the angles? Inside the triangle. So they are interior angles. Exterior angles are. They literally named it what it was. Now, the Triangle Sum Theorem, we know this already. Any three angles in a triangle add up to be 180. Any three angles in a triangle add up to be 180 degrees. And there's different ways that we could prove that that's true or show that's true. But it will always work out that any three angles add together to be 180. Because we could take the triangle and copy it over 3 times and line up A, B, and C, and it'll show us that they make a straight line. Or not so much the triangles themselves, but if I take this triangle and cut the 3 angles out, purely just the angles, and line them up, it will make a straight line. It'll make it so that it's 180 degrees, is one of the proofs for it. But knowing that, we can look at this first example problem. Find the value of x and classify the triangle by its angles. So when we look at this here, we're told that one angle is 47 degrees, one angle is 58 degrees, and the other angle is x. Well, any three angles in a triangle add up to b. So x plus 58 plus 47 is? The next thing we can do is combine like terms. Well, since 58 and 47 are on the same side of the equal sign, we can just add them together, which 105. Now we can subtract 105 so we can get x by itself. Because 105 minus 105 is 0. So we're just left with x on the left-hand side. 180 minus 105 is? So the value of x is? And if we name this triangle based off its angles, what kind of triangle would we have? So we can say an acute triangle. It didn't ask for sides, but most likely it actually would be scalene. It would be scalene. The sides would not be the same. But at this point here, we can't really say that because we have not, y'all don't have the properties to be able to show or prove that that is true. But there is a property of correlation between angles and sides that would let us say that. Questions on this here? We'll look at this one here and then we'll move on to the next types. Well, we have a triangle and 3 angles inside the triangle. And we know that these 3 angles add up to be 180. We can combine our like terms, which would be and then we would 117 from 180. How can we name this triangle based off its angles? Why is it obtuse? Because it has an obtuse angle, 96 degrees. An obtuse triangle. Any questions on these here? Well, let's move on to this one here. Because I think y'all feel pretty comfortable, especially if we're just given one angle. Or one angle is x and the others are numbers. So let's move on to this problem here. Now we're given 2 angles that have variables. One of them's 2x and the other is x minus 6. But what do we know about any 3 angles in a triangle? They add up to 180 degrees. So we can say that angle 2x plus the angle x minus 6 plus, what's the other angle? Is equal to 180. So even though they are all not numbers, we don't have numbers for 2 of them, we only have a number for 1 of them, we can still find out what x is. Well, 2x plus x is 3x. Negative 6 plus 90 is plus 84. Because since we do have like terms on the same side of the equal sign, we can go on and combine them. 2x plus x, negative 6 plus 90. And then we can 84 from both sides. We wouldn't do anything with the 3x because are all the x's on the same side of the equal sign? Well, yes, so we're going to try to move everything else to the other side. 84 minus 84 is 0. So we're just left with 3x is equal to now what can we do? Divide both sides by 3. So x is equal to and that's what it asks for, yes? Find the measure of each. We have to plug it back in. Since one of the angles is 2x, well, it's going to be 2 times 32. 2 times 32 is? So this angle up here is 64 degrees. The other one is 32 minus 6, which is 'Mmh. And if we wanted to check it, we could say 64 plus 26 plus 90. I said 26 and wrote 29. Well, 6 plus 4 is 10, so 0 carry the 1. Well, 9 and 1 is 10. So do they add together to be 180? Yeah. that's it. Questions on this here? Well, this one here, did they give us a single value for an angle? Because I about said number, but well, we do have 40, 17, negative 17, and negative 5. We do have numbers. They're all part of expressions, yes? Can we still find out what x is? Because what do we know about the sum of all three of these angles? That still equals 180. So we can say 3x minus 17 plus x plus 40 plus 2x minus 5 is equal to 180. Well, we can combine our like terms, 3x, x, and then we'd have our negative 17, 40, and negative. And we can add all those together. 18 is equal to.
So would you just do like negative 17 plus 40 plus 5?
Yes. We could do it that way, or we can do 40 minus 17 minus 5. Any of those in any order would work. Because we can do negative 5 minus 17, which would be negative 22. 40 minus 22 would still be 18. So any way you want to add or subtract to combine those like terms. What would we do next? Subtract 18 from both sides. Those would cancel out, leaving us with 6x is equal to 162. And last but not least, by, because 6x divided by 6 is x. 162 divided by 6 is because 6 goes into 16 2 times, which would be 12, which would leave us with 4. Bring down the 2, 42, 7 times 6 is 42. Or if we did 162 divided by 6 in the calculator, we should get 27. And this one asks for each of the angles values. Okay. So it didn't actually specifically ask for the angles themselves, but we need to know what the angles are to be able to classify it. So what we can do is, well, because for x plus 40 would be 27 plus, which is 67. Okay, this angle is 67 degrees. And exactly we can do 3 times 27 minus 17. I just typed it in. Because we could work it out and do 3 times 27, which would be 1, carry the 2, 81 minus 17. Which would give us, 3 times 27 would be 81 minus 17, which would get us back to 64. And 2 times 27 minus 5 would be what? So the actual value of x was 27. And this here would be a what kind of triangle? It would be an acute triangle. Questions on this here? Corollary to the triangle sum theorem, the acute angles of a right triangle are complementary. Well, complementary means what? Add up to 90 degrees. Well, okay. Let's say we didn't say that, but we did have this set up. That the measure of angle A plus the measure of angle B plus 90 degrees, since it's a right triangle, is equal to 180, yes? I don't know what A and B are, but I can get them by themselves by subtracting 90 from both sides, yes? Which would still leave me with the measure of angle A plus the measure of angle B, but now it's equal to what? 90. Would it be wrong to go on and solve it like we've been doing, setting all three angles equal to 180? Well, no, it'll still give me the same answer. But the other two angles will add together to be 90. Wait a minute. This one here is a right triangle, yes? 64 and 26 add together to be. So really, when we solve this, we could have done 2x plus x minus 6 is equal to 90 and gotten the exact same thing. Because if we do this here, it'd be 3x minus 6 is equal to 90. Add 6 to both sides, which tells me 3x is equal to 90, which is the same thing we got. So setting them equal to 90 for any right triangle will work. But if we don't remember that, we can still add all three angles together and have it equal 180. Either one will work. So this here, it is a right triangle. Wait a minute, classify the triangle by its angles. It would be a right triangle because it has a right angle. And then we can set 2x minus 2 plus x plus 5 equal to what? 90 degrees. Is equal to? Then what can we do next? It shows me 3x is equal to, and then both sides by 3. And I believe all it asked was the value of x. Yes? I mean, if it asks for the angles, all we've got to do is plug it back in. Any questions on any of this here? I think we feel pretty good with this here. Well, that moves us to the last theorem that we're going to learn today, the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. Not adjacent, not next to, the opposite to interior. Now, the interior angle at where 1 is and at C, I'm going to call C. Or better yet, let's not call it C. Let's call the interior angle 2. Just so we're not confused on what we're talking about. Now, instead of just saying this and moving on, I want to actually show this to you. Now, what we've learned and what we know so far is that the measure of angle A plus the measure of angle B plus the measure of angle 2 equals what? 180. And we can call the other two angles A and B because there's how many angles at the spot? 1 at angle A, there's exactly one angle. B, there's exactly one angle that we're looking at. Now we reference the other angle as angle 2 because, well, we have the exterior angle 1 and the interior angle 2. So we have this here. Now, measure of angle 1 plus the measure of angle 2 would equal what? Because they make a straight line, yes? According to our transitive property of equality, what did it say? If A is equal to B and B is equal to C, therefore A is equal to C. Well, this statement's equal to 180, this statement's equal to 180, so I can set the two statements equal to each other. So we can say that the measure of angle A plus the measure of angle B plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 2. That's fine and dandy, yes? But what is on the same thing on both sides? The measure of angle 2, yes? Well, realistically, I could subtract it from both sides. Because no matter what that measure is, if it's the same on both sides, I can take it away from both sides. It will cancel out. Which really just tells me that the measure of angle A plus the measure of angle B is equal to the measure of angle. Wasn't that what that property just said? And that's it. That would be a proof. This here is a proof of the exterior angle theorem. Because we use the property of triangles, or the sum of the interior angles of a triangle, to say that the three angles inside the triangle add up to be 180. We use our linear pairs. Angles 1 and 2 are linear pairs, so they add up to be 180. Transitive property of equality said we can set it equal. Use the subtraction property of equality, and well, hey, the opposite two interior angles is equal to the exterior angle every single time. Let's look at some examples. Here, what is the measure of the exterior angle? And this would equal to the sum of the opposite two interior angles, which are? So if we add those two together, we would get the exterior angle. Questions? This one here, it didn't ask us, it didn't put x on the outside as the exterior angle, it's one of the interior angles, yes? And we would subtract, because the exterior angle is equal to the sum of the opposite two interior angles. The exterior angle here is 122, and the opposite two interior angles are x and 90. Well, to solve, what do we need to do? Subtract 90 from both sides. So, I mean, x equals 122 minus 90 technically is correct, because that's what we did. Questions on this here? So this one here, the exterior angle is still equal to the sum of the opposite two interior angles. Yes. The exterior angle is 100 degrees. This one opposite interior angle is 2x plus 3 plus the other angle, which is 51. We can combine like terms. So 3 plus 51 is? And then what can we do? Subtract 54 from both sides. So 2x is equal to? We would divide both sides by. And if we wanted to, we could plug it back in to find out what the angle is, if we wanted to. Did it ask us to find that? No, it just asked to find x. So we're good. Any other questions on this here? I think there's this one. There's two left. Let's do one more because I think doing two more is not going to help y'all understand this any better than one more. Which one would y'all want to do more? 17 or the one after it? Okay. This one here wants us to find the measure of angle 1. Yes? Now, we know that the three interior angles of a triangle add up to be 180. Yes? But do we know anything about the measure of angle 1? Well, we know it's right there, yes? But are we given anything to define it as? We can't label it as x because we can't say for sure that the value of x and that angle would actually be the same thing. We can't really say much about it. But what we do know is that our exterior angle, 5x minus 10, is equal to what? 3x plus 40, the sum of the opposite two interior angles. Because the opposite two interior angles are 3x and 40. So if we add those two together, it would be the same as the exterior angle. Well, we don't have any like terms on either side of the equal sign, so we can go on and start solving for x. What can we do first? We can add 10 to both sides, which will tell me that 5x is equal to 3x plus 50. 5x minus 3x is equal to x is equal to. So we found the value of x. Does that tell us what the measure of angle 1 is? No, but it helps us find it. Because I can plug x back in. 3 times 25. Yeah, let's write over here. So the top angle here is, and we know that these three angles here add together to be. So the measure of angle 1 plus 40 plus 75 is equal to subtract 115 from 180, and we see that the measure of angle 1 is 65. So the measure of angle 1 is 65 degrees. I'm going to erase this here. Now, there's another way we could have gone about this. I mean, after we found out that x is 25, I could have found the angle over here, 5 times 25 minus 10. 5 times 25, 5 is going to be 125, minus 10 is 115. So we know angle 1 and 115 add together to be so the measure of angle 1 is 65 degrees. Well, essentially we'll end up doing the same type calculations. It just may look like it's in a different form. or may show up in a different form. Any questions on this? That is the end of chapter 5.1. Your assignment is on page 213, problems 11 through 17, 19 through 21, 27 and 28. I believe 27 and 28 are both error detection. There is something wrong with the way they set it up or phrased it or how they talked about the problem. You need to, one, identify what the problem is, actually write it out, explaining or kind of saying what they did wrong, and then correcting it. So there are two parts to the error detection. It's not just fixing it or saying they're wrong, because if you just write there's an error, I'm just going to count it wrong. Because you have to identify the error and correct it so you get the right answer of what it should be. If you do have questions on that, please let me know.